The type of the crystal structure, right? So there are total 7 kind of crystal structures. First one was cubic, tetragonal, orthorhombic, hexagonal, trigonal, monoclinic, and triclinic. Right? I have shared the examples of all 7 so that you could have the clear idea how they look like. Okay. So here's a cubic. This is a example. See. Yeah. This is a cubic. A is equal to B is equal to C. Alpha, beta, gamma all are at 90 degree. Second one is hexagonal. A, B. Okay, no, I have made you know that. Tetragonal, right? So A is equal to B, but not equal to C. Okay, so C is different from A and B. And angle are same. You can clearly see here, this line and this line is equal. And this is the symmetry. Okay, so this one is equal to this one, and this one is equal to this one. And same, this is the bottom and this is the top. So top area and bottom area are same. But you can clearly see this height, this line is different from the rest of the edges. Okay, that's why A is equal to B and B is equal to not equal to C. I mean, so A and B are equal, that would not be equal to C. Okay, but angle are alpha, beta, and gamma all equal to 90 degree. As you can see here clearly, all angle are at 90 degree. Okay, similarly, these are the examples of hexagonal. AB not equal to C here, but angle are A, B, sorry, alpha, beta is equal to 90 degree, but gamma is not equal to 90 degree, but they have the definite angle which is 120 degree. Okay, as you can see here in the given example. Okay, this is the example of hexagonal. Okay, so orthorhombic or known as, sorry, rhombohedral or trigonal. As you can see here, A, B, and C all are equal, but the angle between the alpha, beta, and gamma, none of them are equal to 90 degree. As you can see here, they are tilted at all edges. The length of the edges are same. AB is equal to A is equal to B, B is equal to C, but the angle between them are not equal to 90 degree. Okay, so they are tilted. Okay, now orthorhombic A, B, C, none of them are equal to each other. Okay, the angle between them are equal. So alpha, beta, and gamma is equal to 90 degree. As you can see here, this line is not equal to this line, not equal to this one. All are having different length. Okay, they look similar to the cubic, but the difference is the length of A, B, and C are not equal. Though angle of alpha, beta, and gamma are equal in cubic, here you can see here, right? But here you can see it's a little bit, you know, it has not a symmetry, right? In cubic, you have a symmetry figure, but in a orthorhombic, you not having a symmetry figure. A, B, and C are not equal, though angle between them all are equal. Okay, so now monoclinic, in this, none of the size is equal. So A not equal to B, not equal to C, but the alpha, beta, sorry, gamma, alpha and gamma are equal, but beta are not equal to 90 degree. Okay, so these two angles are at 90 degree, but rest 3 1, this is the gamma, sorry, beta, which is not equal to 90 degree. Okay, now come to the triclinic, in between, none of them are equal. I mean, so A not equal to B, not equal to C, and angle between them are not equal to 90 degree. Okay, anything, any angle could be in between the edges could happen, but the 90 degree would not be happen here. Okay, so these